Welcome to the Louisiana Tech University TA1B project demonstration. The demo is for our work on the active authentication of smartphone users based on how they execute touch gestures on the screen, how they type, and how they move while they hold the phone. The philosophy behind this kind of authentication is that users have a unique cognitive fingerprint of how they interact with technology, for example, how they use a smartphone in this case. By defining and extracting features that best model this cognitive fingerprint, we are able to non-intrusively authenticate users while they go about their activities on the phone. A part of our demo is about a new family of robotic attacks that we have designed to test these kinds of authentication systems. Our robots very closely mimic human swiping and are meant as a rigorous performance evaluation tool to motivate the design of active authentication systems that overcome the most sophisticated adversaries. Here, we present the swiping component of our active authentication system. The woman in the top left corner of the window is swiping on the touchscreen as she reads content on the phone. While she executes touch gestures on the screen, our system extracts features that model the different aspects of her swiping behavior and feeds them to the authentication module. The block on the right side shows some of these features as extracted from a single touch stroke on the screen. The model of the phone shows a geometric representation of the features for a single touch stroke. To the right of the phone, a more straightforward definition of the features is given. In the top left screen, the user is swiping on the phone while she reads. The active authentication application on the phone is operating in training mode, meaning that the user's swiping pattern is being stored as a reference template against which future authentication decisions will be made. In the top right screen, the same user later swipes on the phone during the testing stage. The graph in the bottom screen shows the match score between the user's swiping pattern and the template stored during training. The score is always above the yellow threshold line, showing that the user is successfully identified by the system. Another user in the top right screen is masquerading as the user in the top left screen whose template was stored earlier. The match score below the yellow line implies that the authentication system rejects the masquerading user. The second component of our system is authentication based on body movement patterns. The phone in the lady's hand captures her acceleration in the X, Y, and Z directions while she walks. From these acceleration readings, our system extracts a number of features, some of which are shown just below the video. The features undergo a number of processing steps, including, but not limited, to removing the gravity component, fixing the frame of reference, and removing of outliers. The video on the left demonstrates a scenario in which body movement data collected from a user is compared with data collected from the same user at a later time. The first floor plots on the right show the user's acceleration in the X, Y, and Z directions and the resultant of these accelerations. The lower plot shows the authentication score, which is high, that is, above the yellow threshold line most of the time, implying that the user is being positively identified by the system. In the bottom left screen, a different user masquerading as the original lady on whom training was performed is rejected by the system as seen from the authentication match score, which is always below the threshold line. We are currently carrying out tests on a larger population to evaluate the performance of this system. The last component of our authentication system is the typing module. Here, a user is composing an email while the system extracts features such as the key hold times and interkey latencies. The figure on the right shows an example of the features that our system extracts from a string such as ABC. We are currently working on the initial performance evaluation of this typing component of the system. As part of our research, we have also designed a set of robotic attacks that we envision to be the performance evaluation benchmark for these types of authentication systems.
Hello, my name is Now. How are you doing?
We demonstrate one of these attacks based on the humanoid Now robot. On the left, a human executes a touch stroke, which is sent via a local wireless network to the server, from where the robot reads it and executes an imitation of the stroke. Observe that the robotic stroke is very similar to the human-generated stroke. Now is not only matching the path, it is also closely matching raw features such as the time, distance, and starting and endpoints as seen from the graph. An adversary without access to an advanced Now robot can also design a similar attack using the much simpler LEGO EV3 robot. The EV3 robot on the screen uses 3 motors. One motor drives the robot along the breadth of the phone. A second motor drives the robot back and forth along the length of the phone, while the third motor moves the robot vertically on and off the screen. The object being used to touch the screen is a piece of Play-Doh attached to a AA battery. On the phone on the left, a human executes a stroke. On the bottom right of the screen, the Lego robot makes 3 imitations of each human stroke. The graph in the top right screen shows how closely the various features extracted from the robotic stroke match those extracted from the human stroke. Observe that the Lego strokes very closely match the human strokes. Our trimodal authentication mechanism combining typing, swiping, and body movements is one of the techniques we are using to overcome these kinds of attacks. In general, by combining these modalities, it becomes exceedingly difficult for attacks such as those due to robots to succeed. In addition, we are investigating liveness tests that can delineate between a human and a robot while not being intrusive. Thank you so much for your time and attention.